everyone, I hope you are all doing really great. Welcome back to my Tech Learning channel. So today's session is majorly focusing on vector store retrieval memory, which is designed for long-term embedding based memory. So to capture and the complete examples of how to use it, right? Before we get started, if you haven't subscribed to my channel, please go ahead and subscribe and give it a thumbs up. And if you have any specific topics, please put it in the comment box. Okay. So now let's see what is vector store retrieval memory, right? Basically, it stores the it's a memory that actually stores the conversation history as vector embeddings in a vector database and retrieves semantically relevant past interactions. Okay, so based on the user input, this enables basically long-term memory that scales well without preserving entire long chat history, full chat logs, right? So it allows you the semantically similar based retrieval process. That is why vector store retrieval memory will be very much useful to handle the long conversations where you can pull the required or the relevant semantically retrieval of the chats. So what are the key features vector store retrieval memory offers, right? It stores the chat context in the vector store via embeddings. It retrieves the relevant past documents based on like semantical similarity. It supports sync and async APIs. It could be like save context, or it could be load memory or a clear. It integrates with the n number of vector DBs like FAISS or Chroma or Milvus or any of the vector DBs, it would be integrated. Okay, now let's see how to do it in reality, right? So I'll just create a file called conversation vector memory.py. Then I will just copy the one which we may need, the common ones. Okay. Let me wrap this up. Okay. So here we need OpenAI. We need to have the vector related, right? Conversation chain is required. Prompt template is required. Now I'll have to remove this and I'll start importing the one which I need for vector store. So from LangChain, OpenAI, import. No, wait. What am I doing? I'm just from LangChain dot memory dot vector store import vector store retriever. Hope my spelling of retriever is correct. Conversation chains is fine. Prompt template we have it. Now for the vector DB we will just use FAISS. So we'll use vector stores import FAISS. Then from embeddings, I need embeddings also, right? LangChain dot embeddings import OpenAI embeddings. Okay. So I have to see if I have OpenAI embedding. Okay, fine. So next what I'll do here is I have initialized this LM, which is fine. Now I'll create the embeddings. Embeddings equal to OpenAI embeddings. Okay. Then I'll say vector store dot as retriever of equal to 1. Okay, then I will have memory equal to vector store retriever memory. Then I'll have retriever equal to retriever. Okay, then I'll have memory key equal to, then I'll put history. Then I will have, this is mainly to load the history slot the prompts. Then I'll put return docs equal to false. I don't want full docs to be shown. Okay, then I will have a prompt template I have to define. So prompt equal to prompt template. Then we will have input variables equal to history, input. Okay, then I have template equal to conversation. Then I'll put history here. Okay, then I will have user. Then I'll have input. Then I can give you AI. Okay, this is about the prompt. Now let's see memory we have to save. We will have to create a conversation. So I'll just copy paste the one which I have a little bit of on the conversation chain. Just paste this where you tag LLM, memory, prompt, and the verbose. Okay, now I'll also copy the ready conversation which I had kept it handy. Save input. I love this. So this is the conversation I'm going to save. Next, I will also use memory for the conversation, and we'll see how is it responding. Okay, so you can see I have given conversation predict. What did I tell you about movies? Then it will give you the response. Okay, and the last we will say history. We can just try to print it. Okay, so you can say history memory load variables, and then it should be able to print those memory. Okay, so let's try to run it. Okay, let's see if there is any errors. What it is saying? So let's see what is the issue. Vector store is not defined. It should be there. It should be there. Wait. I did not define that. So I'll have to put the embedding ones. Let me just take the relevance of the vector. So we have changed this to the embedding from the Azure OpenAI, and then have initialized this. So let's try to run it now. Okay. What did I tell about movies? You said your favorite movie is Inception. History input. What did I tell about movies? So it has given you the conversations. Okay, this is how the vector memory works. So now let's see one of the simple flow where how this in the real world scenario it works, right? So Milvus integration code flow where you have this Milvus the data source coming in, and this is the vector DB which embeds the data and put it to the vector DB, which could be the data chat logs, then retrievers, and then it will be used within the memory, right? So key pitfalls and the tips, what you can do is avoid storing the non-conversational keys. Like if your prompt includes other contexts like doc, may mistakenly store it. So you can exclude this using these particular key. Not ideal for the agents. You may have to fix it by return docs equal to true. So overall, you can say that it retrieves a semantical retrieval. Okay, it works with multiple vector DBs. It gives you efficient for the long session memory, and you can handle certain kind of recall control by the case. So that's it about today's session. I hope you liked my session, and if you have any specific topics, please put in the comment box, and please do subscribe to my channel. Thank you.